The cybersecurity industry is absolutely full of noise right now. If you spend any time online, you're bombarded with boot camps selling shortcuts, courses selling certificates, and these endless threads promising you a fast track to a six-figure career. Let's just cut right through all of that. I'm going to speak to you directly today, not as an instructor trying to sell you something, but as a working cyber architect. In this explainer, we're looking at the path most engineers actually walk. It's a battle-tested roadmap, and it exists simply to help you invest in yourself.
So who exactly is this for? Well, this roadmap is designed for current cybersecurity engineers and really anyone walking the path to become one. Whether your aim is federal service, private industry, or maybe you're building toward both, the foundations are exactly the same. And I want to make a really specific note here. There is a dedicated track in this roadmap for transitioning military veterans. If that's you, listen closely when we get to that section, because your military training is real currency in this field. This entire model we're looking at was actually built by a Marine veteran and a GS-15 cyber architect. It's completely grounded in reality, not theory.
Okay, here's our blueprint. 1. The essential frameworks. 2. The V-Model architecture. 3. The 5-layer method. 4. Certifications and real experience. And 5. The veteran advantage. Let's dive in.
Section 1. The essential frameworks. As a working engineer, you don't need to memorize every single word, but you absolutely must understand the purpose of the 4 essential frameworks that every architect relies on daily. First up is NIST 800-53. This is your core control catalog. It tells you exactly what right looks like for any DoD or enterprise system. Next is NIST 800-160. This one is crucial because it focuses on secure systems engineering, so integrating security into the actual development lifecycle. Then we have NIST 800-207. This is zero trust architecture. And look, if you're engineering for 2026 and beyond, this is simply non-negotiable. Identity, device, and workload trust have to be continuously verified. Finally, there's NIST CSF 2.0. This is the language private industry speaks. It translates technical controls into boardroom conversations. If you ever want to move between federal and commercial work, you absolutely must be fluent in this one.
Moving right along to Section 2, the V-Model architecture.
Now we're getting to the absolute centerpiece of the roadmap. This is how we take those frameworks and actually integrate security into the engineering lifecycle, rather than just bolting it on at the very end. This is the V-Model software development lifecycle, overlaid with the 7 steps of the risk management framework, or RMF. Most engineers learn RMF as this totally separate workstream from system engineering, like a paperwork track that just runs alongside the real build. And honestly, that is exactly how you end up with a system that passes an authority to operate, but still gets owned. This model fixes that. If you walk left to right around this V-shape, you step through RMF steps 1 through 7 in perfect order.
Think of it like this. On the left side of the V, you decompose and design. You categorize while you write system requirements. You select controls while you architect. You implement those controls as actual design elements, not as documentation. Then, down at the bottom, you build. On the right side, you integrate and verify. Every phase on the left has a verification activity on the right that proves it actually works. And here's the critical punchline. By overlaying RMF directly onto these engineering phases, the framework stops being compliance paperwork and actually becomes security engineering.
Now that diagram is a great mental model, but there's actually a complete step-by-step walkthrough table in your downloadable PDF toolkit. It details exactly what you should be doing at each phase, directly mapping the RMF step to the engineering action. I highly recommend keeping it on your desk as a permanent reference.
Section 3. The 5-layer method.
Knowing the rules is great, but when you walk into a real-world environment, you need a methodical way to pull the architecture apart in your head. Senior architects do this by walking the stack sequentially in 5 layers. Layer 1 is physical, so the hardware, the cables, the server racks. Look, if someone can just walk in and physically pull a hard drive, your firewall rules literally don't matter. Layer 2 is network, how devices talk to each other, routing, segmentation. Layer 3 is storage, where the data actually sits and how it's protected at rest. Layer 4 is the system layer, the operating systems, the virtual machines, where the compute actually happens, and frankly, where most attacks land. And finally, Layer 5 is security, the controls layered on top of all that, like identity management, EDR, and logging. Understanding this progression is exactly what separates the engineers who only know a single lane from the architects who can see the whole board.
Once you've walked those 5 layers, there is always one final check. You just ask this exact question. What software are we using that we didn't talk about yet? Just state it plainly like that, because I guarantee you this question catches the legacy applications, the random browser extensions, and the shadow IT that nobody bothered to put on the initial architecture diagram. Every single time you ask it, something falls out of the woodwork.
Section 4. Certifications and real experience.
All right, let's talk about building your credibility. Certifications tell employers you know the rules, but they really need to be stacked in the correct order to build genuine, undeniable expertise. Walk this pathway in order. Please don't skip ahead. Phase 1 is Security Plus. This establishes your baseline and opens doors to SOC Tier 1 and junior analyst roles. Phase 2 is CISSP. This broadens your knowledge and is a hard requirement for mid to senior engineering roles. Phase 3 is the CISSP ISSEP. This signals deep security engineering principles. It proves you don't just know the controls, you actually know how to engineer them in. Phase 4 is your PMP. This teaches you project management and stakeholder leadership, basically taking you from an executor to a driver. Oh, and if you are heavily in a cloud lane, adding the CCSP after your CISSP is a really great optional addition.
Now, obviously, certifications are just paper without real experience. But you don't have to wait for someone to hire you to give you a lab. Your lab is already in your house, right now. Your phone, your laptop, your Wi-Fi router, your smart TV, every single one of these is a system with a stack. You can start bridging the experience gap tonight just by walking those 5 layers on the devices sitting in your living room. What network does your smartwatch sit on? Where is its data stored? Is it encrypted? Anyone, anywhere can start generating real cyber reps immediately.
Section 5. The Veteran Advantage.
I want to take a moment and speak directly to our transitioning service members and veterans. Listen closely to me. You are not starting from scratch. You are starting from an incredible advantage. Your military training is literal currency in this field. Think about it. You already have military-grade security experience. You've lived a 24/7 OPEC mindset. You implicitly understand compartmentalization, classified information handling, and need to know. You have deep experience in regulated environments, threat identification, weapons handling, and close combat. You've been trained from day one to follow technical orders and keep the watch. That operational discipline, that is the exact foundation that civilian cyber is built on, and most civilians have to try and learn that from the outside in.
Because your background is so rich, you really need to keep a wide aperture. Your competencies map to a much wider set of civilian roles than just a straight cyber engineer title. Look at roles like physical security manager, ComSec custodian, background investigator, or a facility security officer, an FSO. These adjacent roles value your exact skill set incredibly heavily. They can serve as a super fast hiring bridge job to build your civilian credibility while you pursue the engineering path on your own timeline.
For those of you aiming at federal roles, there are 2 high-leverage keys you absolutely need to know. The first is DoD 8140, which is the framework mapping DoD cyberwork roles directly to required certifications. Just match your cert stack to an 8140 role, and you've got a direct line to federal positions. The second is the DoD Skill Bridge program. This allows you to do a literal industry internship during your last 6 months of active duty. That is, quite frankly, the most powerful move a transitioning member can make.
Okay, everything we've walked through in this explainer today is detailed in the full Cybersecurity Engineers Roadmap PDF. Download it, use it as your map, and please remember that you do not have to walk this path alone. The Cyber Command community has working architects, mentors, and coaches who are ready to answer your questions. Show up, ask those questions, and when you can, help the person coming up behind you. Investing in yourself is the biggest investment any human can make in this universe. You carried the fight then, and you are more than ready to lead it now. The roadmap is in your hands, but that first step, that's entirely yours. So I'll leave you with this. Which layer of your own architecture are you going to reverse engineer tonight? We are here to support you. Go, Team Pro Human.